can assist you or tutor you more. If you have more questions, just email me. 16 says the 180 pounds man climbs up the ladders and stops at the position shown after he senses that the ladder is on the verge of slipping. Uh-oh. To determine the inclination of theta of the ladder, if the coefficient of static friction between the friction pad A and the ground is 0.4. Assume the wall at B is smooth. The center of gravity of the man at where the man at is G. Neglect the weight of the ladder. So a few sentences you really have to interpret to be able to draw the free body diagram. It says this wall is smooth. That means there's no friction. It doesn't mean there's no normal force, right? Everything will have normal force. Okay, as long as there's contact between two subjects, there's normal force. Okay, so that's why when we touch the ladder over here, we draw a normal force. But it's smooth, that's why there's no friction. That means it's free to slip up and down. Right, there will be no friction going this way at B. So G over here, right, 180 pounds, and the weight of the ladders is not being included. So that's convenient. And so yeah, friction pad over here as well. There's only a normal force apparently. There's not. There's other forces, but that would be the friction force. Sorry, going to the X direction. And it should go this way, right? Because MB is pushing it this way. There must be a force going opposite. And also, you know, if you stand on the ladder, it will go down, right? So it's not going to push the ladder spin this way. It's going to spin it this way. So it's going to spin. It's going to make point A slip to the right, so that's why the friction is keeping it to the left. All right, as we always do, find the global equilibrium, right? Sum of the forces in the y direction equals to 0, going up is the positive, right? So that means 180 minus plus NA, normal force at A equals to 0, NA is 180 pounds. And then we use the sum of the forces in the x direction equals to 0, right? So that is MB equals to FRB, right? You know, friction at B. So that is 180 times 0.4, which is 72 pounds. All right, here we go. So we found all of the forces. So now we can apply the sum of the moments equation, right? Let's write it over here, some of the moments. So we can do B or A. Let's do A. Get rid of most amount of forces here. So sum of the moments at A is equals to 0. So MB times this distance over here, but we only know the 3 Newton foot, so that would be times 10 feet times the angle over here, which is cosine of theta, right? And since NB is going to make a clockwise rotation, right? So it's negative. It's negative. And plus the 180 pounds goes through, you know, it's going to make a rotation. The distance between this force and the point is over here perpendicularly, right? So that is times, let's say, 10 feet times, sorry, my bad. This is sine. This is sine of beta. Right, this is sine of beta, sorry. Yeah, it's this direction, distance over here. 10 feet times the cosine of theta, right, gives you the distance over here, and minus 3 feet, right, equals to 0, because we're looking for this distance over here. So minus this 3 feet. And that's it. So simplify the equation a little bit, right? Minus 3 feet over here. So that would give us, I mean, we can simplify it, or we can just type this into the calculator, because there's a sine beta and there's a cosine beta. If you're trying to solve it on your paper, it's gonna take you forever. Okay, trust me. And you have a TI 84 calculator, so stop trying to show off, right? If you're genius like Sheldon Cooper, then go ahead, right? Do in your head and find out what beta is, but theta is. But if not, use your calculator, right? Graphing calculator. All of you should have one as a sophomore, or just engineering major in general. What you can do is hit, I'm using a TI 84 plus, so go to, y equals, and then just type in the exact numbers, right? Type in exactly what's been written down over here, right? Exactly what's been written down over here. NB, right? Well, NB, this is 72, right? And plug everything, all the numbers that we know. So negative 750 times sine of, so set theta equals x, right? Plus 100 and 1,800 foot-pounds times cosine of x minus 3 feet, right? This whole thing gives you 0. Plug this into your calculator and hit, and then go to Windows, right? Go Window top bar, the second to the top, and then set x minimum to 180, and then x maximum equals 180, because this is a degree, right? This is a degree, so it's 180. And you can use what is it? You can use the pi over 2, which is radians, right? You can use that as well, but this is a lot more accurate. So when you set all of the domains, so I set x minus 180, x max is 180, scale is 18, or x minimum, y minimum is, doesn't really matter at minimum. So after that, hit graph, right? And then you will see your graph it out, and then hit second trace, which is calculate, and then hit values, right? That won't tell you anything. I'm sorry. Go hit second and it should go to 0. Sorry, and then it's gonna, hit left and right bounds, right? So once you see the left bound, hit the left bound of the value, the x, where the x intersection, the positive one, not the negative one. The negative one would just be 180 minus the positive. And then hit the right and left bound, guess, let's say in between, right? And then x should give you 52 degrees. This is the purest form, right? Because we wrote it in cosine of x, right? We didn't just say cosine of x equals a number, right? So here you go, x equals 52, so that's also theta, and that is the end of this video, right? Theta is 52 degrees. Hopefully this video was helpful. It's relatively, simple one once you really understand what the heck the question is talking about, right? I had such a long time deciding, whether the pad has a friction force, right, or the, what is going on at the smooth point over here at P, right? But after, when you understand what the question is asking and able to draw a free body diagram, you are good to go. You see, this is sum of the forces in x and y. This is, arithmetic simply over here, and this here requires you to use your calculator, graph it, solve for x. So yeah, good luck, and I'll see you in my future videos. Bye. If you have more questions, specific questions you would like me to do, please comment in the comment section down below.